Hello viewers, in today's session we are going to discuss some very important and conceptual problem from vectors, right? So in this class we'll solve some variety of problems related to the dot product of vectors and the cross product of vectors, right? So let us start and let us first take this problem. So here we are given two vectors, vector A and vector B, such that the magnitude of vector A is 3 and magnitude of vector B is 4, and the magnitude of the sum of the vectors A and B is equal to square root of 5, right? And then we have to find the square of the dot product of vector A and vector B, right? So in order to solve this problem here, we are going to use an important concept from the scalar product of two vectors, and that is square of a vector, that is square of a vector is equal to square of its magnitude, right? So this is an important concept to solve these kind of problems. So we can write square of a vector. Suppose we have a vector, say x, then the square of this vector x is equal to the square of the magnitude of vector x, right? So here we are given this magnitude of vector a plus b. Then we can use this concept by taking vector x is equal to the sum of the vectors a and b. So the square of the sum of the vectors, that is the magnitude square, is equal to a plus b square. So the square of the vector, that is vector a plus vector b, is equal to the square of the magnitude of the sum of the vectors a and b, right? So here we'll write this vector as a plus b dot a plus b, right? So the square of this vector may be written as the dot product of the same vectors. So now multiplying the vectors, we have vector a dot vector a plus vector b, then we have vector b, and then we'll take the dot product of vector b with this vector a plus vector b, right? So now taking the dot products, we have vector a dot vector a, then we have a dot b, and here we have b dot a, and here we have b dot b, right? Now this is a dot a is equal to the square of the vector a, and here these two terms get added because the dot product of two vectors is commutative, right? So a dot b is equal to b dot a, so we have 2 times a dot b, and here we have the square of this vector, right? So again using this concept, the square of a vector is equal to square of the magnitude of the vector. So here we have simply the square of the magnitude of vector a. Here we have 2 times a dot b, and here we have the square of the magnitude of vector b, right? Now the magnitude of vector a is given as 3, so here we have 3 square plus here we have 2 times a dot b, and we have to find a dot b square, so we'll keep it as such. And here we have the magnitude of vector b as 4 square, right? And here the magnitude of vector a plus vector b is given as 5, so here we have root 5 square. So this is simply 5, this is 9, this is 2 times a dot b, and here we have 16, right? So solving this equation for A dot B, we have 16 plus 9, 25. So we have 25 plus 2 times A dot B, and taking 25 to the left hand side, we have 5 minus 25 is equal to 2 times A dot B, and here we have A dot B is equal to 5 minus 25 is minus 20 over 2, so this is minus 10, right? So the dot product of vector A and vector B is equal to minus 10, but we have to find out the value of the square of the A dot B. So A dot B square is equal to minus 10 square, that is 100, right? So this is how we can solve this type of problem. So now consider another problem. So here we are given two vectors A and B, which are unit vectors, right? So it implies that the magnitude of vector A and magnitude of vector B is equal to 1. And these two vectors are such that the sum of the vectors A and B is also a unit vector, right? Then we have to find the angle between vector A and B. So here we are given a vector, say this is vector A and this is vector, say vector B, right? And we have to find the angle theta between these two vectors. So here we are given that the magnitude of vector A is equal to magnitude of vector B, because both the vectors are unit vectors, so their magnitude is 1. And the vector A plus B is also a unit vector, so it implies that the magnitude of vector A plus B is also equal to 1, right? And we have to find the angle between vector A and B. So what we will do, we'll try to find out the dot product of vector A and vector B. So we have to get an expression of this type, that is involving A dot B, because A dot B is equal to magnitude of vector A, magnitude of vector B, and here we have cosine of theta, right? And magnitude of vector A is 1, magnitude of vector B is 1, so we have 1 1 and cosine theta, right? So we have simply cos of theta. So A dot B is equal to cos theta. So from here we can easily find out the angle between vector A and vector B if we know the value of the dot product of A and B, right? So again we'll make use of the important result, that is square of a vector is equal to the square of its magnitude, right? So now if we take vector x as the sum of vector A plus B, then here we can write the square of the vector A plus B, taking x vector is equal to vector A plus vector B. So here we have the magnitude of A plus B, and then we have a square, right? So now this quantity is equal to 1, because A plus B is a unit vector, so its magnitude is 1. So here we have 1 square, that is equal to 1. So we have obtained this equation, that is square of the vector A plus B is equal to 1. So now taking the dot product with uh, A plus B with A plus B, right? So this is equal to 1. So taking A dot A plus B, and then we have B dot, uh, here we have A plus B, and now we have A dot A is equal to the square of vector A, then we have A dot B, and here we have B dot A, and B dot B is square of the vector B, right? Now the square of the vector A is equal to the square of its magnitude. So the magnitude of vector A is 1, so here we have 1 square, that is 1. And similarly here we have square of the vector B, and here we have the square of the magnitude of vector B, which is 1 square, that is 1. So here we have 1, and these two quantities get added because the dot product of two vectors follows the commutative property, right? So A dot B is equal to B dot A, so here we have 2 times A dot B, and here we have 1, that is equal to 1, right? Now A dot B is equal to cosine theta, so we have 1 plus 2 cos theta plus 1 is equal to 1, so we have 2 cos theta plus 2 is equal to 1, right? 2 cos theta and 1 plus 1 is 2, so we have 2 cos theta is equal to 1 minus 2, so this is 2 cos theta equal to minus 1, so cosine theta is equal to minus half, right? So now from trigonometry, we know that when theta is equal to 120 degrees, then cos of 120 degrees is equal to minus half, right? So the angle between these two vectors A and B is 120 degrees, that is 2 pi over 3, right? So the angle between the vectors A and B is equal to 120 degrees. Now let us consider this important problem. So here we are given this expression, that is the square of the magnitude of the cross product of vector A and vector B plus the square of the magnitude of the dot product of vector A and vector B is equal to 400, right? And the magnitude of vector A is given as 10, and we have to find the magnitude of vector B, right? So this is a very important problem, and this problem belongs to a special category of problems which can be solved using the famous Lagrange's identity in vector algebra, right? So let us first see the Lagrange's identity, and then we can apply that identity to get the solution of this problem. Now suppose we have two vectors. Suppose this is vector A and this is vector B, right? And if theta is the angle between these two vectors, then the Lagrange's identity says that the square of the magnitude of A cross B plus the square of the magnitude of A dot B is equal to the product of the square of the magnitude of vector A and the square of the magnitude of vector B, right? So this identity is known as the Lagrange's identity in vector algebra. So now here we can easily see that this quantity is already given as 400. So here we can write 400, and here the magnitude of vector A is given as 10. So here we have 10 square, right? And here we have the square of the magnitude of vector B. So this is 400 times 100 times that is the square of the magnitude of vector B, and here we can cancel this 400 with 100, so we have 4. So here we have 4 is equal to the square of the magnitude of vector B. So the magnitude of vector B is now equal to square root of 4, right? because we can take the square root of both sides. So here we have 2, right? So the magnitude of vector b is equal to 2. So now consider another very important problem. So here we are given two vectors, vector A and B, and both these vectors are unit vectors inclined at some angle theta, right? So here we have vector A and here we have vector B, and these two vectors are inclined at an angle theta. Then we have to show that the magnitude of the sum of the vectors vector A and vector B is equal to 2 times cosine of theta over 2, right? And again, to get the solution of this problem or to prove this expression, we have to make use of the important result, that is square of a vector is equal to the square of its magnitude, right? So viewers, this result plays an important role in vector algebra to solve different kind of problems, right? So again, utilizing this result, what we will do here, we'll take vector x as the sum of the vector a and b, right? And moreover, we are given that vector a and vector b are unit vectors, so their magnitude must be equal to 1, right? So now applying this result, we have the square of the magnitude of the vector a plus b is equal to vector a plus b square, right? So now we have here a plus b square. So taking the dot product, so we have vector a plus b times the dot product here, a plus b, right? So now taking the dot product a with a plus b, and then we have b dot a plus b. So now we can write here a dot a, which is the square of the vector a, and this is a dot b, and then we have b dot a, and this is b dot b, that is square of the vector b. Now the square of the vector a is equal to square of its magnitude, and here these two get added because a dot b is equal to b dot a, right? Because the dot product of two vectors obeys the commutative law, right? So here we have 2 times a dot b, and this is square of the magnitude of vector b. So now this is 1, this is also equal to 1. So we have 1 plus, this is 1 square, and this is 2 times a dot b, and a dot b is magnitude of vector a, vector b, and cos of theta, right? And here we have the square of the magnitude of vector b, which is 1 square. So we have 1 plus 2 times 1, this is 1. From here again this is 1, so this is cos theta plus 1. So this is 1 plus 1 is 2, and this is 2 cos theta, right? Now we can take 2 common, so here we have 1 plus cos theta. So now we have obtained this expression, that is the square of the magnitude of vector a plus vector b is equal to 2 times 1 plus cos theta, right? So now here we'll make use of some trigonometry, and from trigonometry we know that the half angle formula. So 1 plus cos theta is equal to 2 times cos square theta over 2, So here we can take 1 plus cos theta is equal to 2 times cos square theta over 2. So we have 2 times 2 cos square theta over 2, that is 2 times 2 is 4, 4 cos square theta over 2, right? So now here we have the square, so we can take the square root of both sides, that is the positive square root, because we are dealing with the magnitude of vectors, right? So here we have a square root of 4 cos square theta over 2, and that is equal to the square root of 4 is 2, and here the square root get cancelled with this square, so we are left with 2 times cos theta over 2, right? So the magnitude of vector A plus vector B is equal to 2 times cos theta over 2, and this is what we have to prove. So now consider another problem related to projection of a vector on another vector, right? So here we have to find the value of lambda when the projection of this vector A on this vector B is 4 units, right? So viewers, we have already discussed in detail related to the projection of one vector upon another vector in our previous videos, and here see we have this vector A, and suppose this is our vector B, right? Now the projection of vector A on vector B is given as 4, so the length of the projection is given as 4 here. So the projection, it goes like this: we draw a perpendicular from the tip of this vector A on a vector B, and suppose this is O and this is M, then OM is the projection of vector A on vector B, right? So the direct result for the projection of a vector on another vector is given by OM is equal to A dot B divided by the magnitude of vector B, right? So here vector A and vector B are given in terms of components. So A dot B can now be written as lambda I cap plus j cap plus 4k cap, and here we have the dot product with 2I cap plus 6j cap plus 3k cap, and in the denominator we have the magnitude of vector B, which is the square root of 2 square plus 6 square plus 3 square, right? Now the length of the projection OM is given as 4, so here we have 4. Now to get the dot product of these two vectors, we multiply the II components, then JJ components and KK components, right? So we have lambda times 2, and then we have here the coefficient of j cap is 1, so we have 1 times 6, and then we have 4 times 3, right? And in the denominator we have square root of 4 plus 36 plus 9, so this is 2 lambda, and this is 6, and this is 12, and here we have square root of 9 plus 4 is 13 plus 16 is 49. So we have 2 lambda plus 18 is equal to 7. The square root of 49 is 7. So now we have this equation: 4 is equal to 2 lambda plus 18 over 7, and multiplying 7 with 4 we have 28, then we have 2 lambda plus 18, and this is a linear equation in lambda, so we have 2 lambda 28 minus 18, and this is equal to 10, right? So lambda is equal to 10 over 2, that is equal to 5, right? So viewers, the value of lambda when the projection of vector A on vector B is given to be 4 units. So now let us take another very important and conceptual problem, that is for any two vectors, vector A and vector B, we have to show this inequality, right? That is the magnitude of the dot product of vector A and vector B is less than or equal to the product of the magnitudes of vector A and vector B, right? And this result is the famous Cauchy squares inequality, right? So here to prove this inequality, what we will do, see if we take vector A and vector B as zero vectors, then let us see what we get. So if the vector A is a zero vector, then we can easily see that here we have the magnitude of zero vector dot vector B, and here we have the zero vector, right? And here we have the magnitude of vector B. Now this quantity is 0, right? And here we have 0. So we can see that if this vector A is a zero vector, then the inequality holds, right? Or 0 is equal to 0, so the inequality holds. And similar is the case with vector B. If vector B is a zero vector, then again we can write here the magnitude of vector A dot zero vector. Then we have here vector A, and here we have the zero vector, right? So now this quantity is 0, and this quantity is 0, so this is the product is 0. So we can see that when either of the vectors, that is vector A and vector B, are equal to the zero vector, then the equality holds, right? So let us now prove this inequality for two vectors, that is for two non-zero vectors. So now let us assume that vector A is not equal to vector 0, and similarly vector B is not equal to the 0 vector, right? Now let us start with the dot product of vector A and vector B, which are inclined at an some angle theta. So here we have vector A, and here we have vector B, and these two vectors are inclined at some angle, say theta. So the definition of the dot product of vector A and vector B is given by the magnitude of vector A, magnitude of vector B, and cosine theta, right? So now let us take care of this term. Now see, from trigonometry we know that cosine theta has the minimum value, that is -1, and the maximum value as 1. So we have this famous inequality from trigonometry. Now this result can also be expressed like this, that is the mod of cosine theta is less than or equal to 1, right? So the modulus of cosine theta is less than or equal to 1. So from here we can now write cosine theta is equal to A dot B divided by the magnitude of vector A and magnitude of vector B. So substituting this value of cosine theta over here, we have mod of A dot B, and then we have here the modulus, the magnitude of vector A and vector B, and this is less than or equal to 1, right? So now simplifying this term, we can now take the mod of A dot B, and then in the denominator we have the magnitude of, because both these quantities are positive, so we can simply write the magnitude of vector A and vector B over here, right? So now since the vector A and vector B are not equal to 0. So multiplying both sides by this product, we can now write the mod of A dot B is less than or equal to, that is magnitude of A times magnitude of vector B, right? So this is the famous Cauchy-Squarz inequality for two non-zero vectors.